To achieve this, you can utilize the advanced features of OS Route 53. For instance, Route 53 allows you to set up latency-based routing. This means that when a user tries to access your application, Route 53 can direct them to the nearest server, minimizing the time it takes for the data to travel. Additionally, you can implement health checks to monitor your servers. If one server goes down, Route 53 can automatically redirect traffic to a healthy server, ensuring that your application remains available. In summary, using Route 53's advanced DNS features helps you optimize performance and maintain high availability for your global users. Route 53 is not just a simple DNS service, it is a highly available and scalable solution designed to provide low latency resolution for users all around the globe. This means that it can handle a large number of requests efficiently and quickly, ensuring that users get the information they need without delay. To get started with Route 53, the first step is to register or import your domain. Once that's done, you create hosted zones, which are like containers for your DNS records. After setting up the hosted zones, you define record sets that tell Route 53 how to respond to queries about your domain. In summary, understanding the full capabilities of Route 53, beyond just basic DNS, is crucial for effective use. By following the steps of registering a domain, creating hosted zones, and defining record sets, you can leverage its powerful features. When users from around the world send requests, these requests first reach the edge locations of Route 53. The routing policy then determines which resource, such as an EC2 instance, an elastic load balancer, or an S3 bucket, will respond to that request. This is crucial for ensuring that users get the best possible experience based on their location and the current state of the resources. Additionally, Route 53 uses health checks to monitor the status of these endpoints. If an endpoint is found to be unhealthy, a failover mechanism is triggered, redirecting traffic to a healthy resource. Think of it like a traffic light system. If one route is blocked, the system automatically directs cars to an alternate route to keep everything flowing smoothly. In summary, Route 53's routing policies and health checks work together to ensure that user requests are handled efficiently and reliably. In our lab, we will create a hosted zone, which is essentially a container for managing DNS records. Then, we'll configure EC2 instances, which are virtual servers in the cloud, along with Elastic Load Balancer, ELB, endpoints that help distribute incoming traffic. After setting these up, we will implement weighted and latency-based routing policies. These policies will help us direct user requests to the most appropriate server based on their location and the current load on each server. Additionally, we will attach health checks to ensure that if one endpoint becomes unhealthy, traffic will automatically be rerouted to a healthy one. Think of it like a traffic management system that directs cars to the fastest route while avoiding any roadblocks. In summary, these routing strategies are crucial for maintaining a smooth and reliable user experience. To validate that everything is functioning correctly, we can use tools like DNS Lookup and CloudWatch metrics. These tools help us monitor and check the health of our endpoints. However, there are common mistakes that candidates often make in this area. For instance, they might confuse failover with latency routing, ignore important health checks, or misconfigure record sets. In summary, understanding how to properly manage global requests and the importance of health checks is crucial for maintaining a robust network. When we implement geolocation routing, it's crucial to ensure that we understand the correct use cases for each routing policy. This means we need to configure health checks and failover mechanisms effectively. Additionally, Conducting thorough global latency testing is essential to ensure that our routing decisions are optimal. If we skip these steps, we risk poor performance and availability for users in different regions. Think of it like a delivery service that needs to send packages to various locations. If they don't check the best routes or have backup plans in case of road closures, packages might arrive late or not at all. In summary, using advanced DNS features like latency-based, weighted, failover, and geolocation routing is critical for maintaining global high availability and performance. Proper testing and validation are key to making these features work effectively. First, it's crucial to understand that health checks are essential for ensuring that your application is running smoothly. They help monitor the status of your resources, like servers or databases, and make sure they are functioning as expected. If a resource fails a health check, it can be automatically removed from the routing, ensuring that users are directed to healthy resources only. This leads to a better experience for users and maintains the reliability of your application. Now, when we talk about routing policy selection, it's about choosing the right way to direct traffic to your resources. For example, if you have multiple servers, you might want to use a routing policy that sends traffic to the server that is closest to the user. This can improve load times and overall performance. In summary, remember that health checks and the correct routing policy selection are essential for maintaining a robust and efficient application.